Hi, I'm Farhana and welcome to the series on trigonometry rules. In this lesson, we're going to be focusing on the sine and area rules. So let's get into it. Have you ever thought about if it's possible to solve a triangle and get two different sizes for the same angle? Well, that's the question we're going to answer today. But first, let's look at the concept map. So, in the last lesson, we dealt with solving non-right angle triangles and specifically the sine rule. We're going to continue with that and we're going to be discussing the sine rule today, but specifically, we're going to be dealing with the ambiguous case of the sine rule. Now, before we begin, let's do some vocabulary. What does the word ambiguous mean? In this case, ambiguous means that in certain situations, there can be two possible solutions. So let's see how this applies to the sine rule. Okay, if you recall the sine rule, it was a simple rule to memorize. Sine A over A equals to sine B over B equals to sine C over C. And we had the reciprocal version. Can you remember what that was? It was the version with the sides on the top. So it was A over sine A, B over sine B equals to C over sine C. Now, can you remember when we applied the sine rule? What did we need to check for? Okay, can you remember? We needed to have one full pair and one half pair. So anytime we use the sine rule, we needed to make sure we had one full pair. So in other words, either we could have been given two angles and a side, or two sides and an angle. And remember, it cannot be the angle that's included. We will come to that a bit later. Okay, so what is the ambiguous case? So the ambiguous case of the sine rule occurs when we have two sides and an angle. So basically when we're given side, side, angle, as we said earlier. But there's an additional condition. If you look at the diagram that we have on the side here, you'll notice that we're given a full pair in terms of 6 and 33. So this is our full pair. And our half pair is 10. And the angle across it is what we could find. So if we were solving this triangle, we would start off by solving for angle B, using the full pair of 6 and 33 and the half pair of 10 and B. So the ambiguous case occurs when we're given the full pair, but the full pair contains the smaller of the two sides. So if you notice that this side, AB, is smaller than the other given side of the half pair, which has the dimensions of 10 units. Okay, so just to recap again, ambiguous case occurs when we can use the sine rule, but specifically when the pair that we are given contains the shortest of the two sides. Let's continue. Okay, so in this case, you'll notice we can draw, we'll be able to draw two different triangles using the same information. Let's look at how we can do that. Okay, if we're given triangle ABC, AB is equal to 6, AC is equal to 10, and angle C is 33. Then we would draw the triangle like this. Okay, so we've got AB is equal to 6, AC is equal to 10, and we have angle C, this angle here, being 33 degrees. Now again, we've got to test to see if this is the ambiguous case, and again, it's the same diagram as earlier. So remember the full pair that's given contains the shortest side. Now, why is this an ambiguous case? Why can we draw two different triangles? they've not given us any information about this angle A here. So they've not given us any information regarding this angle here. If you imagine there being a pivot on this angle at A, then this line AB, which has a length of 6, could actually be drawn like this. If the line is drawn here, it has the same value of 6, but now the angle value of A has been reduced a little bit. So it means we're ending up with two different triangles. We're ending up with this little blue triangle here, we're ending up with this larger triangle here with the same values, or we could end up with a smaller triangle with B being in this position instead of this one. What does this mean about the angles? So if you notice, there's something strange happening with the angles here. Okay, so in this case, B would be an acute angle. And in this case, angle B would be an obtuse angle. So we need to account for it. And just something to note as well, if we pivoted AB to this position here, to the second position here, you do realize you're going to end up with these two sides being equal. And so we have created a little bit of an isosceles triangle. And if we needed to calculate this angle, we could do that by using adjacent supplementary angles here. Okay, and that's one way we could find the two different versions of angle B. But let's look at those diagrams again, a little neater version of it. In this example, we're given triangle ABC with AB equal to 6, AC equal to 10, and C equals to 33. So we would draw the triangle like this. But if we fill in the values, AB is 6, AC is 10, and C is 33, the full pair we're given contains the smaller side, so it is an ambiguous case. And why it's ambiguous? Because they've told us nothing about this angle A here. And if you imagine that angle A there's a pivot at angle A, then we can take this line AB and turn it in such a way that we can draw it instead like this. Now, drawing it like this gives us a whole new triangle, a smaller triangle, but it gives us this triangle here, A, B, C. It means AB is still 6 in the smaller triangle, AC is still 10, and C is still 3. So what we've created now is two different triangles with the same information. Now, because we have two different triangles with the same information, a smaller triangle and a bigger triangle, it means we can have two different values for our angles A and C. Let's look at what our two triangles will look like. Our first triangle is exactly as we drew it, so that's the big triangle. In this case, angle B will be an acute angle. And the second triangle that we can draw with the same information now has B bigger than it was earlier, and now we have the obtuse angle B. Okay, so now that we've done one example, let's try another example and see if you can see how we can draw two triangles with the same information. In this triangle, we're given that AC is equal to 9, and we're given BC is equal to 7, and we're given the angle A is 45 degrees, which is this angle here. Okay, is this the ambiguous case? Again, how can we tell if it's the ambiguous case? We need two conditions. What are the two conditions that we need to have? We need to make sure that we have one full pair. There's our full pair and one half pair. So we've met the first condition. the second condition we need to have is we need to see if the side that's given in our full pair is smaller than the other side. And 7 is smaller than 9, so we fulfilled our second condition for the ambiguous case. Now, it means we can take side BC and either we can draw it here or we can draw it in this position here. So we could draw B in that position, or we could draw, we could draw BC in this position, or we could draw BC in this position. Okay. So our two triangles will look like this. There's our first triangle, the larger triangle, and in this case, we can see that BC is here and B is an acute angle. Our second triangle that we can draw is this one, and it's with the smaller, with the BC turned inwards, and this angle is now an obtuse angle. Okay, we're going for a quick ad break, and as soon as we come back, we'll be looking at how we can apply this ambiguous case to solve a triangle when we are given side-side angle.